Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing sets and we shall be dealing with general problems. The Venn diagram shows the number of elements in each region. Find n of A intersects B complement. So we want to find the number of elements in A intersects B complement. B complement is the region outside of B. And A is, of course, the region inside of A. So the intersection between both of these are the region of intersection here would be this region, which has 3 elements. So therefore, the answer here is 3. Now we have an element is chosen at random. Find the probability that this element is in set B. So the total number here is 12 plus 7 plus 3 plus 5. And therefore, the total number here is 27. So the probability is 19 over 27 because B has 7 and 12. So it has 19 elements. So 19 over 27 is the probability. In C, we are told an element is chosen at random from set A. Find the probability that this element is also a member of set B. So in set A, the total number of elements is 7 plus 3. So this is the total. This is in the denominator. We want the probability that it is also a member of set B. So it has to be one of the 7 that is common between A and B. So therefore, the answer is 7 over 10. We can tell that 3 and 19 over 27 and 7 over 10 are the correct answers here. The Venn diagram shows information about the number of elements in sets A, B, and the universal set. The number of elements in A union B equals 23. Find the value of X. So A union B is this part and this part and this part. So we can set up an equation 20 minus X plus 8 minus X. All of this is equal to 23. Now we can simplify. So negative X and positive X cancel out. So we just have 28 minus X equals 23. And you can take the 28 to the other side. So negative X equals 23 minus 28. Negative X equals negative 5. So X equals positive 5. And this is the final answer. In B, we are told an element is chosen at random from the universal set. Find the probability that this element is in A union B complement. So let's redraw the Venn diagram, having figured out the value of X. So we have two sets like this. We have 5 in the middle. We have 3 on the side because we have 8 minus X. 8 minus 5 is 3. And 20 minus 5 is 15. So we can put 15 in the left circle. And then we have 7 outside. We want the probability that the element is in A union B complement. So A union B is whatever lies inside the two circles. So the complement is the region outside. And the region outside has 7 elements. So the probability is going to be 7 divided by the total. The total here is 15 plus 5 plus 3 plus 7. So the answer is 7 over 30. So A is correct, X equals 5, and B is correct as well, 7 over 30. Here we are given the total number of elements in the universal set, which is 20, and the number of elements in P is 10, the number of elements in Q is 13, and the number of elements in P union Q complement is 5. So first of all, P union Q complement means the number of elements outside of the two circles is 5. And we should always put X in the region that is common between P and Q because this is the unknown part. We do not know the number of elements that lie between P and Q. This is actually the target here. This is what we're trying to figure out. So in this case, we're trying to figure out X. And in P, we will have 10 minus X. And in Q, we will have 13 minus X, because the total in P is 10. So X and 10 minus X. And the total in Q is 13. So X and 13 minus X. Now that we've figured out what to put inside the Venn diagram, we can set up an equation: 10 minus X plus 13 minus X plus 5. All of this is equal to the total number of elements in the universal set, which is 20. Now we can cancel out minus X and plus X, and we have 10 plus 13 plus 5. This gives us 28 minus X equals 20. You can take the 28 to the other side. So negative X equals 20 minus 28. Negative X equals negative 8. So X equals positive 8. So the answer is positive 8. This Venn diagram shows information about the number of students who play basketball, football, and hockey. Find the number of elements in B union F intersects H complement. So let's first try to shade the required region here. We have H complement, so we will shade that in one color. Actually, let's just redraw the Venn diagram to do the shading without ruining the diagram in the question. We have 3 circles here. We have B, we have F, and we have H, and we have 12. Excuse me, we don't really need the 12 here for the shading, never mind. So we want to get B union F intersects H complement. So B union F is everything inside B and F. This is B union F. And then H complement is everything outside of H. So we shade everything that is not touching H. So the common area here, the area that has both blue and green, is this area. Everything outside of H, but inside of B union F. So in the drawing, in the actual diagram, we're looking for everything outside of H, but inside of B and F. So 2 and 7 and 6. So 2 plus 7 plus 6 gives us 15, and that is our final answer. The Venn diagram shows the number of elements in each set. Find n of P dash intersects Q. So P dash is the region outside of P. And then Q is the region inside of Q. So we want the overlapping region here. The overlapping region would be the part that has both blue and black, which is the part that I colored in red. And the answer, of course, would be 10. In B, we are told complete the statement n of what equals 17. So we are looking to find the number of elements that gives us 17. So of course here, if you try to add up 9 and 3 and 5, you get 17. So we want the elements that are represented by 9 and 3 and 5. So how would we be able to represent this? This is basically everything except the 10. So this is P union the complement of P and Q. Because P consists of the 3 and the 5, and then P union Q complement consists of the 9. So therefore, we join them together in order to get 17. So the answer is 10 for the first one, and P union Q complement for the second one. but our expression would also work. In A, we are told n of the universal set is 10, n of A is 7, n of B is 6, and n of A union B complement is 1. Complete the Venn diagram by writing the number of elements in each subset. So we have to start by putting x in the common area. And then here we have 7 minus x, and we have 6 minus x on the right, and we have 1 outside. And then we set up our equation. So 7 minus x plus 6 minus x plus 1 equals the total number of elements, which is 10. We can cancel out negative x and positive x. So 7 plus 6 plus 1 gives us 14 minus x equals 10. We can take the 14 to the other side. So negative x equals 10 minus 14. Negative x equals negative 4. So x equals positive 4. Now we can plug in the actual numbers in the Venn diagram. So we have 4 here, and 2 here, and 3 here, and the 1 outside. And if we add these up, we get 10. So we know that we are on the right track. An element is chosen at random. Find the probability that this element is an element of A complement intersects B. So let's draw a Venn diagram outside just to figure out which region to shade. This is A and this is B. So we can shade B, and then we can shade A complement. And we try to figure out where the colors overlap. A complement is everything outside of A. So the colors obviously overlap in this region here, which is inside of B but outside of A, which is basically the 2. So the probability is 2 divided by 10. So 2 over 10 is the correct answer, and 3, 4, 2, and 1 are correct as well. Here, this is a simple question. We are just required to find a subset of Q. You can choose any set that has some of the numbers in Q. So 1, 2, and 3, for example. This would work as long as you have numbers from these 6 numbers and that you do not include all 6 of the numbers. So you cannot just write 1, 2, 3, 4, 5, 6, but you can write anything else. 1, 1, 2, 1, 2, 3, 2, 3, 4, 4, 5, 6, any combination of numbers, as long as you do not put in all 6 numbers. Complete each of the following statements. A intersects B. So A intersects B here. We're looking for the common numbers between A and B, and the only common numbers here are 2 and 5. The number of elements in B is 3. You can just count them. 0, 4, 6 equals intersection of what and what? Of course, this is the intersection between the universal set and A. Excuse me, of course, this is incorrect. It's the intersection between A and something else, but we do not know what that something is. So we want 0, 4, and 6. So it has to be something outside of B. So it cannot be 2 or 5. So it has to be B complement. So the intersection here is B complement intersects A, not the universal set, because the universal set intersecting A would just give you A. So that would not be right. Finally, 2, 4 is a subset of A. And these are the correct answers. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.